Hey everyone, welcome to Hack.py, our second workshop on Introduction to Python 2. If you guys went to the first workshop, we covered basically the fundamentals of Python, so some basic stuff, just getting introduced to variables and other very basic concepts of Python. In this workshop, we're going to be doing some more advanced stuff, but still intro stuff to Python. So we'll be covering functions, classes, sorting, and a few other data structures that you may be familiar with or not if you're new to Python, but we'll be going over that all in this workshop. So I'm going to pass it on to Henry, who's going to begin presenting this workshop. Our two presenters today are Henry and Maggie, both great presenters. And yeah, let you guys get started.
Yep, so sounds good. Welcome back to Hack.py. Today we're going to be going over Introduction to Python 2. So we'll be going over a bit more advanced topics, including functions, classes, and some of the data structures that you can find in Python. So let's go ahead and get into it. For information, resources, so the slides are posted at acmurl.com/hackpy2, and then the repo for this workshop will be posted at acmurl.com/hackpy. So I'll leave that up for a couple seconds in case y'all need it. All right. So first things first, so in this workshop, we're going to be going over functions. So we should talk about what functions are before we actually try writing them. So functions are basically blocks of code that can be called and used at any time. And so these functions are usually really good if you have like long segments of like repeated code that you don't want to keep having to write out all the time. If you just define it in a function, then you can basically call that function at any time and basically access that code and execute it whenever you want. So here we have this simple function called greet. And so what this greet function does, it basically just prints out hello world to the user. It basically, whenever you call it, it'll just print out hello world to the console. And so this function can be called without being given any parameters. And so what parameters are basically anything that you pass in within the parentheses of the function. So if you think about functions as sort of these like input output kind of boxes, you can pass stuff into it and then it will output something for you. Now, it won't always necessarily have an input and it won't always necessarily have an output. But in general, these are what functions tend to do, is that they basically allow you to execute certain blocks of code without having to worry about having to write it all over again every time you try to do it. So this function, like we said, it can be called without being given any parameters. So here we don't pass anything into the greet function. But what if we do want to pass something into the function? So let's talk about passing in data. So let's expand upon our greet function by passing in like a name and a time. So here, what we're going to do is we're going to pass in a name variable as well as a time variable. So here, these are called parameters, and it basically explains what this function has to take in. So here, our greet function will have to pass in a name and a time. And then here, what we're going to do is we're going to print out a statement using one of the format strings I warned about during the last workshop. So here, what we're going to do is we're going to print out good, whatever the value of the time variable is, followed by the name, and then at last, hope you are doing well. And so here, if we were to pass in David and morning, what this is going to do is it's going to take these values, these are arguments, and it's going to basically put these into these corresponding slots. And it's going to print out good morning, David. Hope you are doing well to the console. I have an example of this right over here. So basically we have it outlined here. We have our greet function, which has basically what we have outlined in the slide. And so if we were to run this, see, it prints out, good morning, David. Hope you're doing well. And so what if we wanted to reverse this? Say we passed in morning over here, and we wanted to pass in David over here. So basically what this is right here. So if we were to run this instead, basically what would happen is that morning would go into this slot right here where it is name, and David would go into time. So instead of printing out good morning, David, hope you're doing well, this will actually output good David morning, hope you are doing well. And so yeah, basically the order in which you pass in these different values, it does matter. So just be careful of that, and make sure that whenever you're filling out like a function, that you are passing in the right values to each of these different slots, because otherwise you could have some nasty errors that might happen because of that. And so yeah. And so in case we don't feel like passing in anything to our greet function, we can also define some default parameters. And so these default parameters will basically tell us that, oh, if we didn't pass in like certain variables into our greet function, then it will just default to the values that we set it to within the function definition. So here, when we're defining the function greet, what we're going to do is we're basically going to set name to a default value of Daniel, and we're going to set time to a default value of afternoon. And then the rest of it is just going to be the same. We're going to have a format string that basically takes in the various values and then outputs it to the user. So if we were to call greet just on its own without any data that's being passed in, it'll automatically default to printing out good afternoon Daniel. But if we were to still pass in some data like David and morning, then it will print out good morning David. So yeah, basically just think of default parameters as sort of these like placeholder values in case you don't actually pass anything in. And then another thing we can talk about when it comes to functions is that we can also decide whether or not our function actually outputs a value once everything within the function executes. And so we can do this using a return statement. So here we have defined a multiply by 3 function. And so what this is going to do is it's basically going to take in a number. So this can be any number that you decide to pass into the function. And what it's going to do is it's going to multiply that by 3 and assign it to a new variable called new num. And then afterwards, it's going to print out done to the console. And afterwards, what we're going to do is we're going to return new num. And so what this is going to do is basically once we have this value, we're going to return that. And basically what happens is that this function call, the value is going to be whatever new num is. So here in this statement right here, we're basically going to print out the result of multiply by 3, where we're passing in the number 2. So what will happen? So let's go ahead and try to type this out. So if we were to basically type out this function, so we're going to have new num equals num times 3, and then we're going to print out done, and then we're going to return new num. And then afterwards, what we're going to do is we're going to print out the value of multiply by 3, and then we're going to pass in 2. So once we do this, and we run this function, what it's going to do, so first, when we call this function, it's going to go into this function real quick. So it's going to pass in 2 to here. It's going to multiply 2 times 3 and store it into the new num variable. It's going to print out done, which you can see right here. And then afterwards, it's going to return the value of new num. And it's going to return it to this part right here. So once we return new num, we're going to print that out. So that ends up being 6, which we print out via this statement right here. And you can see that right here. So basically, what you need to know about this is that when you call a function, it's going to execute all the lines of code within that function. And then afterwards, if there's a return value, it'll basically return that to whatever the function call happened. And so that's basically return statements. Again, return statements are defined using the return keyword. So if you do want to return a value from this function, you got to make sure you have this return keyword in there. Otherwise, it's just not going to do anything. Right now we can do a short example of this. So first, we're going to create a function that computes the area of a circle. And so what you're going to want to do right now is you're basically going to want to, if you don't already have PyCharm installed, what you can do is you can just like go on Google, search up Python online interpreter. So Python online interpreter, and you can basically click the first one, which will take you to this sort of console, or to basically this sort of like file right here, which you can basically do the same thing if you're on PyCharm. And then from here, you can just type out whatever code you want to do. And so what we're going to have you do is basically, we're basically going to have you create a function that computes the area of a circle. And so what we want you to do is basically this function will take in a radius number. So like with multiply by 3, it takes in a number. Here we're going to have you take in a radius. And then we're going to have you return the area. And so if you remember geometry, the formula for computing the area of a circle is roughly pi times r squared. So here we're just going to have you do 3.142 times r. And then after that, what you're going to want to do is you're going to take a user input, store it into a variable, and basically call this area of a circle function with that input. So if you remember from last workshop when we talked about the input function, what you can do is you can call the input function, you can pass in some string to like prompt the user for something, and then that's going to basically take whatever value you typed in and then store it to a variable. And so yeah, we're going to take a couple of minutes to do that. If you do finish early, you can try taking it a step further and trying to create another function that computes the volume of a cylinder. And so basically, you can use the output of your area of a circle function to basically compute the volume. If you don't remember, it's area of a circle times height. And so yeah. But yeah, we're going to take a couple of minutes. David, do you want to go to the Discord for this, or do you just want to live code it right now?
Yeah, I was thinking we can have the workshop tutors join Discord channels, and if you guys have any questions or if you just want to hang out, we'll just be in the Discord channels that you guys can join in. Otherwise, we'll just demo this in a little less than 5 minutes, and yeah, show you guys how to do it.
Yep, sounds good. So yeah, we'll be moving to the Discord now. If you haven't joined our Discord, it's ACRL or acmurl.com/hack-discord. If someone would put it into the chat. And then if you haven't joined, go ahead and join it. Otherwise, we will be in the Discord voice channels and just helping you out from there. So yeah, for now, I will go ahead and sure that you know the difference between using the square brackets as well as the parentheses. And so it looks and behaves very similar to a list, but you want to make sure that you know that it's immutable. And so what immutable means is that you can't change their values based on their index. So say if we wanted to like access the value at index 0, which is 3, and say we wanted to change that to like 4. So we can't actually do that with a tuple. You can do it with a list, but you won't be able to do it with a tuple because it's immutable. And so, yeah, so because lists are immutable, so lists, you can change those values. You can actually append and remove elements from these lists with ease, unlike everything else like sets and other stuff like tuples. So here we have an example of a list. Yeah, so we have a list that has 3, 6, 9, and 12. And from this list, what we can do is we can add the number 15 to it. And so we can do that with this sort of append function. So if we were to print this out, we would get 3, 6, 9, 12, and 15 because we want to add 15 to our list. Now say if we wanted to remove an element from the list, so we can actually say we want to remove the number 12 from our list. Then we can do that. And if we decide to print out the list again, it would print out 3, 6, 9, and 15. And yeah, so I'm looking at the chat right now. Oh, all right. Sounds good. So the recording stopped a little while back, but I think it's all good. So we can keep moving forward. But yeah, so now that we've talked a little bit about lists, now let's see how we can use lists with loops, which we discussed in the last workshop, where you can basically iterate over certain numbers, or basically a lot of different things. So what we can do with this is I can go ahead and type it into here. So what we want to do for this example is say, let's try to create a list of odd numbers from 1 to 50. And so we're going to use this, we're basically going to create this list by using a for loop. So yeah, I can just expand that a little bit. And so yeah, what we're going to do first, we want to make sure that we actually have a list to store these numbers into. So we're going to create a variable that will basically assign to a list. And this is going to be an empty list at first. So it has nothing in it. It's just 2 square brackets and nothing in between. So this will just create a sort of empty list that we can add any value to. And so we want to use a loop to add values to this odd numbers list. So we'll go ahead and do that. So what we can do is we can use a for loop. And we're basically going to say, we can just use like a random variable called like I. Let's just call it I for now. And then basically we're going to have it be in the range of 1 through 50. And if you remember from the last workshop, what this range function does, it basically gives you a range between the first number, which is inclusive, and the last number, which is exclusive. So this will, in actual execution, it will only go up from 1 to 49, but we defined it to be exclusive of 50. So once we have this, then we can go to work on actually adding the numbers to the list. So since we want the odd numbers, what we're going to want to do is we're going to have this if statement that will basically check if I is an odd number. And the way we can do this is basically we're going to mod it by 2, and we're going to check it if it equals to 0. And so as a refresher, what this modulus operator does, it basically gives you the remainder of what I divided by 2 is. So say if I was equal to 5, so if I was equal to 5, then we would try to do 5 divided by 2, and that would give us a remainder of 1. And so since that's not equal to 0, then we know that it's an odd number. So yeah, basically this is how you basically check if a number is odd. You basically just mod it by 2, and then check if it's equal to 0. And if it's not, then that means it's odd. So if it is an odd number, then what we're going to do is we're just going to append it to our odd nums list. And that's all we got to do is we're just going to append the value of I into odd nums. And once this happens, this loop will just keep running through 1 through 50. And then once that's all said and done, then all we need to do is just print out odd nums. And so once we do that, if we were to run this in our script, then as you can see here, it basically prints out the entire list from 1 through 50 exclusive of all of the odd numbers. So that's just 1, 3, 5, 7. And you can also do this within the loop too. So you don't necessarily have to like print it out at the end. You can actually also just like say if you also want to like see this loop in action, you could also like put a print statement within the for loop and basically print it out as it goes. So if we were to do this as well, then it would basically just print out this long string of every time we go through the loop and basically check if the number is an odd number. And by the end of it, we get this full list of numbers. Do you have any questions about what we just did? Okay. Doesn't seem like anyone has any questions so far. So now we'll move on. So now I believe Maggie will go over the next section of the workshop.
Yeah, so let me share my screen real quick to start the presentation. All right, so we're going to cover a little more on lists before we move on to other data structures, because this will be useful in the exercise after this. So as Henry mentioned before, lists are sortable, are changeable, which means we can sort lists. So Python actually provides this sort methods. In the first line of the code, we have the numbers 1, 2, 3, 4 in random order. And if we sort them, it will sort it by ascending order. So it will print 1, 2, 3, 4 after we sort the list. And we can also provide the reverse parameter. So if reverse is set to true, then we can sorted in descending order. And not only can we sort numbers, we can only sort like strings in default it's alphabetical order, and other objects such as flows and charts and tuples. So this is a very powerful tool. So make sure to check out the amazing methods that Python provides for each type. It can be really useful and save a lot of time working. So moving on to other data types. Now we have sets. So sets look very similar to lists and tuples, except that it wraps its data with curly braces. So as you can see, we're initiating data with hello world, and we are wrapping these within the curly braces. And what else is different is that sets are unordered and unchangeable. So what this means is, for example, if data was a list or tuple, if we try to print data 0, we could print the first element that's contained in data. But since we're having a set, this is not going to work because set is unordered, and it's unchangeable, meaning that if we attempt to change something within the set, it will not allow us to. So both these lines will result in an error. And on this line, so I need to emphasize that this is not changing the set itself. It is taking a new set and assigning it to the data variable. So what is being changed here is not the set itself, but the variable data. So this is going to be allowed. And technically, sets should not allow duplicate values, but so I'm going to share my screen, and are we seeing my entire screen right now? Because I need to share my, okay. So let's try to declare a set that has duplicate values. So I'm gonna call it data like we did before, and initialize it with hello, and print data. So if we run this, let's see what it does. So yes, so that's exactly why I wanted to cover this. So even though it's technically not allowed to have duplicate values, it will not throw an error when you try to initialize a set with duplicate values, but it will just, when you try to access it, it will just eliminate the duplicates for you. So that's it on sets. And one of the last built-in data structures for Python is called dictionaries. So dictionaries is pretty similar to sets, but it's unordered and changeable, and each entry is a key value pair. So for example, we have this dictionary called person over here, and each entry is a key value pair, so its syntax is key colon value. So this over here has a key of first name and a value of Maggie, key of age, and value of 20, etc. So you can kind of consider the key value pairs, the keys as the names of the attributes, and the values as the values of the attributes, as the name suggests. And they do not allow duplicates either. So the values can be any type. So we can have strings, we can have numbers, integers, floats. We can also have lists, other data structures as the values. And keys need to be immutable types, such as strings or numbers. So if we go over the example over here, we can access the data within the, oh, I see a message in chat. Okay, yeah, so dictionaries are unordered, which means that we cannot use indices to access its values. But so how we access these values is using this syntax over here. So person is the name of the dictionary, and in the square brackets over here, we're going to put the key of the value that we need to access. So similarly, if we use person first name, we can also set the data to change it to a different person first name, and we can also change other fields as well in a similar fashion. So if we run the code over here, I will try to demonstrate this, showing my entire screen. I'm going to copy paste the code to here. So we have a person declared over here. We try to access the data. We try to update the data, and we have a function call, which prints all the keys within this person. For demo purposes, I will print person again to see how everything has changed. So if we save the code and run it.
Oh, Maggie, make sure you get rid of your old code from the last demo at the very top.
Oh yeah, right. Thank you.
There's a little bit more on line 1.
Oh no. This, I do not want this either. Okay. Okay. So as you can see, person first name successfully accessed my first name Maggie, and after changing the first name and minors, we can see that the data basically changed to Henry's data. And if we print person keys, we will have first name, age, major, and minors, which is the keys that I defined over here. Also, what additional thing that I can do is I can actually insert a key value pair into a dictionary. So, Henry, what's your favorite food?
Noodles.
Okay. So if I save the code over here and I try to run it again. So as you can see, we have Henry's favorite food displayed over here as well. And in the key set, we have favorite food included as well. So that's how we can use the keys to even insert a key value pair into a dictionary. So continuing with the presentation. So right now we're gonna have a practice. So we're gonna create 2 functions to test our knowledge on lists and dictionaries. So first, we will need to create a function that returns a list of powers of 2 up to 2 to the n minus 1. So for example, if we pass in n equals to 3, we will return 2 to the zeros, which is 1, and 2 to the first, which is 2, and 2 to the second, which is 4. Next up, we're gonna create a dictionary of the powers of 2 up to input n, where each key is 2 to the power of that number. So the result of this function will look like this. The starter code is already provided for you over here. So you can just copy paste, make sure to indent it in your editor so that Python recognizes the body of the function. And otherwise, we can start coding. So should we move to Discord for this one as well?
Yeah, let's do this on Discord. So
Okay.
we'll give you guys like 5 minutes to do this, and after that, we'll just reconvene right here. Oh, Maggie, you're still sharing your screen. So if you go back to the slides to make sure that they can see the instructions, thanks. Yeah, so in case you missed that, just to go over it again, we're going to make a function that returns a list of the powers of 2. So for example, like 2 to the 0 would be 1, 2 to the 2 would be, or 2 to the 1 would be 2, 2 to the 2 would be 4, so on and so forth. So this function would take in an input n and return a list of all of the powers of 2 up to that number. So for example, if n was 0, then the list would just contain 1 because 2 to the 0 is 1. If it was 2, it would contain 1 and then 2 and then 4, because the power 2 to the 2 is 4. So we gave you guys the starter code right here. You have the function definition and then an empty list, and you want to fill that list up and then return it. And then once you finish that, you can work on the second function, which is very similar to the first, but instead you'll be making a dictionary where you can use the power of 2 you want to find and return that value using that dictionary. Also, feel free to ask any questions in the chat or just on Discord. But yeah.
What we first want to implement is powers of 2, and we have an empty list. So what do we want to do to insert these powers into this list? Apparently, we have to loop through all the values up until n exclusive, and we want to insert these values into the list. So we can start with a loop because we are running this operation for every value from 0 up until n. So we can say for I in range n. What this does, well, when range is taken in only one parameter, it will range from 0 up to the number. So what we want to do is we want to append the value into the list. So remember, we covered earlier the append method in list. That's how we can insert a value into the end of this list. The value we want to append is 2 to the power of I. So what we're going to do over here is we have I equal to 0, and we will append 2 to the 0's power, which is 1, into the list. And when it goes to 2, it will 2 to the 0 first, which is 1, and 2 to the first, which is 2 next, and 2 to the second, which is 4 after that. So we have list append, and after we finish with that loop, we want to return this list so we can access this value later. And so let's try to print out the value of powers of 2, 3 to make sure our code is working. And I'll comment these out for now. And we are going to run our code. So it's printing out 1 to 4, which is pretty much what we want. So moving on to the second function, def powers of 2 dict. Going to nicely indent these code. Okay, so right now we have our powers of 2n, and we have an empty dictionary. So what we want to do is to have a key value pairs. So what we can do over here is for I in range n again, because we're going to loop from 0 to n-1 all over again, because that's the keys that we're going to use for our data. And for I in range n, we need to append something. We need to add something into the dictionary as well. So remember how we went over how to add some value in the dictionary earlier? So we use dict, and whatever key we're going to use equals to whatever value that we're going to use. So in this case, the keys are going to be I, because, well, we want our keys to be 0, 1, 2, 3, depending on the n that we pass in. And the value will be depending, we don't even have to go to calculate these again, because list already contains the values that we want to use. So what we can do is we can just access that particular index in list to give us a value. And of course, at the end of this method, we're going to return the dictionary in order for us to find out the value. And just to test it, we're going to print powers of 2 dict powers of 2 dict of 3. So let's go ahead and try doing that again. So yeah, we have our desired outcome. So does anyone have any questions regarding this exercise? Oh, thanks, David. All right, so looks like we're good to move on to the next parts. So now that we're basically done with data structures, we've realized that we have called methods such as sort in lists and maybe keys and append in dictionaries. And under the hood, what we're doing is we're calling the sort method of the list class and maybe the keys function from the dictionary class. So every primitive type in Python that we have used up to this point belong to a class. And what classes are is something that we can consider them as templates of objects. And so basically classes can have these functionalities that all of its members, all of its instances can access. And creating a new class creates a new type of object, which you can then make instances of. So a good way of explaining the relationship with classes and instances is, for example, we have a dog class, then this dog is going to be an instance of the dog class because it's a dog. But different instances of dog can be different, such as dogs can have different breeds, they can have different heights, different weights. So that's basically explains the relationship between a class and an instance of a class. So right now we have a simple example of a class. We talked about instances of class before. So when we were creating an instance of a class in Python, we will call the init method of its class. So for example, this init over here, we have breed and bark as its arguments. So it can set the breed of the dog to be the breed provided, and the bark that we of the bark that we provided, and set its speed to 5. So if we notice that there's a very weird parameter called self, this self is actually a necessary parameter of functions in classes. So what self does is self refers to the instance that called this method. So for example, if we have Snoopy, we want to create an instance called Snoopy that's a dog. So self will be defaultly initialized, automatically initialized as the instance Snoopy. And so breed will be beagle over here and bark will be wolf. So now that it knows self refers to Snoopy, it will set the breed of Snoopy to beagle and bark of Snoopy to wolf. And similar here with Pluto, we have different arguments, but it just sets its breed and bark to different things, and self will refer to Pluto. So without the self parameter, it will be really hard to tell which instance we are trying to set the breed and bark and speed to. So this is very necessary. And other than just initializing the instances, we can also define member functions that all of its instances can access. So if we have a class dog going off from the previous example, we can have functions that get and set the properties of the current dog. So we can set the breed of the current dog and we can get the breed. So also we can use the properties of this dog to do cool things, such as we can make the dog speak. So over here we have this speak function that can print whatever self breed plus says plus self bark. So for example, if we initialize Snoopy to be a dog with breed beagle and bark of wolf, then we can set the breed of Snoopy to be golden retriever. So in set breed, self will be initialized to Snoopy, and it basically does Snoopy.breed equals to golden retriever. And if we call a speak method over here, self breed now is going to be golden retriever because we already set the breed in the previous line, and says plus self bark, which will be wolf, which is initialized in the init method, and it will print a golden retriever says wolf. So yeah, self dot in front of property name to specify that we're accessing the property of this instance. So we know that we are referring to doc A instead of doc B. So there are a lot of more examples on class methods. For example, the sort method, as we covered earlier, is a method from the class list. And in a Python interpreter, we can also run help list to see which methods are a part of the list class. That is quite a few of information that we just covered. I'm going to check the chat if you have any questions. Owa? Yeah. Yeah, excludes N. All right. So right now we're going to create a class. So this exercise will combine information that we learned about sorting and classes. And so for this exercise, we'll create a class called order list that will be containing a list that will always be sorted in ascending order. So for example, if we pass in, so the init method will take in a list, which means we need to pass in a list to its arguments when creating an order list. And if we pass in the list 316 and we print order get, which is the method that will return the order list itself, it will print 136, which is sorted. So we'll be moving to Discord again for this exercise. This can be a little challenging exercise to do. So we can have longer time for this exercise, and after that, we can move back to live coding, and I will go through the example, the solution. So, all right, we can Discord it up and start exercising. And feel free to access the previous slides because previous slide has a lot of useful information for this exercise particularly. All right, so now we are ready to go over the example. So before I go over the example, actually, this is one pretty good resource. So in case if you ever need to look at what methods a particular class has, you can always look it up and you can see all the methods that we can have in our list class over here. So yeah, I'm gonna move over to, okay, I was not sharing my screen earlier, but this is what I was referring to, the list of methods and their description. So okay, let's move on to our actual example. So right now we have an order list and we have an init method that takes in a list. So list will be a list. And in order to set the self property of a list, we will have self list equals to list. So what it does is taking the parameter list and assigning it to the list property of whichever instance called the order list init method. And also, because it's an order list, we want to sort the list in ascending order before we potentially use it for anything and we return the values. So in the constructor itself, we will need to sort.
Hey, Maggie,
self
are you
list.
sharing the the code right now?
Yeah, I'm supposedly sharing my entire screen.
You might have to reshare the screen. Oh, there you go. Yeah.
There we go. Yeah. I don't know why it's not showing earlier, but the code looks like this right now. And the page that I was talking about earlier is this. So you can see a list of methods over here. Sorry for the confusion. Okay, so now that we have initialized our list to be properly sorted, we can implement our add and remove function. So what add takes in is an element that we want to add to the list. And what can we do to insert a value into a list? We can call self.list.sort. And in order to add an element into a list, we call the append method. And the argument that we want to append is going to be element. And as always, we want this list to be sorted. So after we once again append the new value into the list, we need to sort it. So after we can add, next thing we're going to do is remove. So if we want to look into how to remove a method in Python, we can go into the remove method that's right over here. And so remove, basically what it does is it will remove a element in the list if it currently exists in it. So what we're gonna do is we're just gonna call self.list.remove this element. And we do not need to sort it again after we remove the element because the list is already in sorted order before we remove this element. And removing this element does not affect the order of this list already. So the last thing that we're gonna implement is the get method of the order list. And all that we're gonna do is we return self.list. So right now we have our class finished. And in order to test if it works, we can create an instance of the order list class. So let's call it OL because it's order list equals to, remember how we initialize a instance of the class? We initiate with a list that we need to provide that sets the self.list. So let's just provide a unordered list that says 1, 3, 2. And we're going to add another value into this OL. Actually, we can print this order list before we do any other operations. So this should return 1, 2, 3. And after this line, we can add a new value into this list. So ol.add, that's how we call a method on an instance. Let's say 0. We can print ol get once again. And lastly, we can try to test the remove method. This removes 3. And get. So this should cover all the methods that we have implemented over here, and we can run the code. Oh, order list has no. Oh yeah, this is a typo over here. It's LST, so make sure to check your spellings when you're coding. So as you can see, OY.get returned the correctly sorted list that is 1, 2, 3, which is in order, and inserting 0 makes it insert at the beginning, and after removing 3, we have our element 3 removed from the list. So do you have any questions regarding this example? All right. So I think that's it for the workshop. And yeah, that's the last slide before the thanks for coming. So I would like to thank you all for coming. And next week, we will have our web development workshop at the same Zoom link. And the slides will be at acnurl.com/hack-by-3. So thank you for coming.
Yep, thank you all for coming. Make sure to come back next week. Yeah. I'll go ahead and stop the recording.
Thank you.